Awesome. Thanks, Sage. Hi, everyone. I'm Niels. I'm part of the ML team here at Union, and I'm super excited to talk about and demo artifacts and reactive workflows. So just as a point of order here, there's a little QR code here interspersed throughout the slides. So if you want to access the slides at some point in the future, you can do so. Okay, so if you're familiar with Flight or any kind of pipelining tool, but I guess I'll refer to Flight specifically. In Flight, functions are really the first class entity. So here, I'm just showing a task or workflow, F, that produces some kind of output Y, and that output is consumed by downstream tasks or workflows, G and H. The way you think about this in Flight is it's useful to think about things functionally, right? So you have compute and there's infrastructure associated with that compute. Takes an input, which is strongly typed, produces an output, which is strongly typed. And this is a great programming model. There's a problem, though, with sort of like accessing the outputs of these functions. So what if I want to access Y here, right? Like say I'm in a REPL or Jupyter Notebook, and I want to access Y and play around with it. Well, today in Flight, you would do something like this. You use Flight Remote to fetch the execution. So execution is sort of like this first class entity that you can fetch. And then here is it's Flight's bias, right? It's an output is like a result of an execution, which makes a lot of sense. But is there a simpler way of doing this? The solution here is that Union is introducing is called artifacts, and it functions now materialize first class entities called artifacts. So in the yellow here, I have artifact Y. And it might seem like a trivial thing, but I'm going to hopefully convince you over the course of this demo that this actually gives you a lot of nice superpowers. So now instead of all of that code, I could simply, in a REPL or Jupyter Notebook, point to that artifact, my artifact, and get it. No referencing executions or anything like that. So that's problem number one. Problem number two is, what if I want to decouple G and H from F? So a use case here is, F trains a model, G evaluates it, and H does batch inference on it. And today, the way you would especially specify these dependencies is, you'd have to strongly couple all of these pieces of compute, or otherwise use Flight Remote to sort of string things together ad hoc. So the solution that Artifacts provides you is that now you can introduce soft dependencies between workflows with artifact queries. So I have artifact Y here, and T minus 1, T minus 2 just simply are just materializations over time of artifact Y. And now G and H can have the soft dependency where I can say, hey, the X of G, the input X, is artifact Y, and I'm just querying the latest materialization of Y. So now I can break out my evaluation step and my batch prediction step with my modeling step. And I think this is quite a powerful shift in the way you think about how to put together workflows. Problem number three, what if I want to run G and H whenever F produces an artifact? So instead of manually running G and H whenever F runs, I want to just do it automatically, right? So whenever F trains a model, I just want to kick these things off. Well, now artifacts introduce this capability of reactive workflows where it's coupling the soft dependency with events. So whenever F finishes computing Y, an event basically is listened to is published, and G and H, you can think of this as pub sub, like G and H subscribe to this event, and now they kick off automatically. The last problem I want to talk about, but probably won't have too much time to actually show you in the code, is problem number 4. What if I want to define variations in the output of a workflow and treat them differently? So today you would there's a way to do this, right? You parameterize F in different ways to produce a version of a data set, for example, data set A and data set B, and you kind of have to factor your code around this variation. Well, what artifacts gives you is the ability to introduce partitions into your artifacts. So you say, hey, I have this partition key kind, so I can produce Y, variation A and B, and think about them logically as the same thing. And now G consumes kind A, and H consumes kind B. You can also do this with time partitions. There's a little bit more syntax associated with this, but you can basically introduce a time dimension to your artifacts and then respond to them accordingly. So quick demo. I'm not actually going to run too much in terms of commands, but I wanted to show you a more realistic example of how this all might work. So I want you to think less about a team managing an entire life cycle of a model. So now we're in machine learning land, where we have different teams managing the different parts of the life cycle of a model. And this makes sense for a lot of organizations. So say you have a data engineering team or a team responsible for creating a training set. So I have this data set script here, and there's a lot of details, but I do just want you to focus on this workflow that creates a data set and just calls a task. And this task produces a data frame, but it's annotated. It has something else. It has additional metadata attached to it. That additional metadata is this NYC taxi dataset artifact. So here, all I'm doing is that this simplest definition of an artifact, I just give it a name. And when I invoke this task, now Union knows, hey, this is a first-class object that I can now reference with this name. Just to make things more concrete, the data set we're working on is the NYC taxi data. So, this is pulling data from the raw, .gov website. So this is not like Kaggle or BigQuery. It's actually pulling the Parquet file from the original source. Quick shout out to Pandera, just to give you a sense of we're doing data validation on this, and it also makes it upfront what all the columns in this Parquet file are. So I've pre-run this, and here's an execution of the create dataset workflow. And everything should look familiar to you if you're a Union or Flight user. But in the outputs, something you might notice is instead of simply the Parquet file with the S3 path, you get this NYC taxi dataset artifact. And it provides all this additional information about what created the artifact. So this links back to this execution, in addition to how to access it with Union Remote, and some more information, right? So I have a card here that is basically just Markdown. We're going to make this richer with images and stuff in the future, but today you can create a dataset card here. And you have a lineage, which I just want to give you a teaser of, these are all the things that depend on or consume this artifact. So now I can get a kind of meta DAG of everything that requires or depends on this one artifact. Just hopping back here really quick. So the dataset card that you saw in the UI is basically just defined here. And when I write my task code that produces an artifact, all I have to do is say, hey, creating a NYC taxi dataset with this data frame, and I want to create a data card associated with it with just more human readable information. So going back to the problem I articulated in the slides, where I want soft dependencies between different workflows. The way I now consume this as a modeling team, I'm in a separate repo. I have separate conventions and whatnot. But now I just want to reference this NYC taxi data set here. I don't have to import any code. The way you would do this before with vanilla flight is maybe with reference tasks or reference launch plans that are cached, and you'd import that in, and you have to do a whole bunch of stuff to access this data set. Now I can just define this here. And when I define my create model workflow, I say, hey, my data is a data frame, but I want the default value to be whatever the latest version of the NYC taxi data is. And so that's it. I train my model, and now I produce an NYC taxi model that is linked to this data set. So I'm creating this lineage of artifacts. It's going to be a gradient boosting regressor that predicts the total fare of your ride based on some features, trip distance, the month, hour, and minute that you were picked up. Ideally, you would have latitude, longitude as well here, but this simplifies things a little bit. And I've pre-computed the model here as well. Same thing with this execution. The thing you'll see here is in the inputs tab that this is the data set that this model was trained on. So this is literally this artifact here in the UI. And it produces an output, NYC taxi model. And here I haven't produced a data card, but this is additional metadata. This is the execution that created the artifact. And here's the lineage of the model and the specific data set that was used to create it. The last thing I want to show you is the reactivity piece. So, you might want to include the model evaluation step in the model training step as well. But there are many cases in which the evaluation step might take a long time. So I think LLMs and a suite of benchmark metrics that you want to compute. Sometimes these benchmarks take a long time. So this might make sense for you to break this out where we have the syntax now with launch plans where you basically say, here's my evaluation workflow. I'm going to evaluate on just the training metrics. So this is kind of a toy example. So I'm going to evaluate on the data set I trained on and the model that I just produced. And I actually want to trigger this launch plan based on whenever a new version of the NYC taxi model is created. So hopefully this will not take too long, but I'm going to actually kick off a model training step. And if I go to the launch plans view here, I'm going to find the launch plan first. This one. And as you can see here, I've triggered this already with a previous model training execution. So hopefully, once this runs, we're not going to wait too long, but you can see that once this create model workflow is completed, this is actually going to trigger a evaluation workflow. So if we click into here, here's the evaluation workflow execution. The inputs are the data set and the model, and the output is this NYC taxi model report. So I click into this artifact, which I defined in the code over here, right? So I'm defining this NYC taxi model report, which I'm going to dump, just mean absolute error metric onto it. So it's a very kind of simple toy example. Here's the model card associated with the report, and here's the lineage of what went into the evaluate model workflow, which is the data set and the model artifacts. And then finally, with inference, I have a batch inference example here. It's fairly simple, but again, I just want to emphasize there are different teams or people responsible for different parts of a machine learning lifecycle, and they may have different, conventions around how they do things, right? So this is a way for us to sort of collaborate and combine different things, objects, data, models that teams produce So this is basically just using just the latest model. There are fancier things here you can do, like partitioning or creating like a deployed or approved model. But in this case, we're just providing a default value for the model being used for batch inference. So this is actually a way for you, with a few more things that we're going to show, probably in a follow-up demo, how you can actually automatically just use whatever is the latest deployed model in your batch inference workflow. So just hopping back into the summary, artifacts basically are first-class data objects in Union. So you can declare them in your tasks as outputs. You can fetch them imperatively. You can define soft dependencies. You can create reactive workflows based on those soft dependencies. And you can create custom partitions based on some arbitrary key or time-based partitions. So you can try these out today. Here are the docs for artifacts and the blog post that we wrote if you want to learn a little bit more.